In this video, we will show you how to install the dependencies of our system, such as PyCharm, Pipe3, and OPC UA Python library. And we will show you how to create OPC UA server and variables, and monitor server variables by UA expert, and also modify read server variables by OPC UA client. And at last, we will show you how to control physical robot by OPC UA client. Our demonstrator environment is the fresh Ubuntu 18 virtual machine, and our host machine is Windows 10. We can install PyCharm by input this command in a terminal. After the installation finished, you can load PyCharm, and we skipped the PyCharm loading time in this video. You also need a pipe tool for Python library installation. You can install pipe tool by input this command in a terminal. You can create a new Python project in PyCharm. Since we are using the fresh Ubuntu system, so we cannot create new document when we right-clicked. And you need to input this command in the terminal. Create a new file and rename it to opcuaserver.py. And change the properties to allow executing as a program. And we need to go to the setting to check the Python interpreter. Currently now I'm using the Python 3.6, and you can check what version of Python you are using now. At the beginning, there's only 3 packages, as you can see it here. We need to install the OPC UA package by click this button and input OPC UA and click the install package. After a few seconds, you will see the notification shows the package installation finished. And you can see OPC UA and OPC UA dependencies in the package list. Now we can say the OPC UA installation is succeed. In this video, I create a demo program for the OPC UA server, and in this demo server, only 6 joint values for the robot are created. You can based on my server program to create your server program. The first thing you need to check is your IP address, since your IP address may be different from my IP address. You can check your IP address by input if configure in your terminal. In my case, my IP address is 10.00118, so I input this address in the program here. In here, 48020 is my port number for OPC UA server. You can change your port number as you wish. In here, I create 6 values, Nachi J1 to Nachi J6 for my Nachi robot joint values here. And I enable these values can be writable. Then I can start to run the program. When you see the message listening on is here, which shows the server is running. Since the server is running, and we also need a software to view the variables on the server. The software is called UA Expert. You can Google UA Expert and download it for free. You can choose the version by your operating system. Since we are using Ubuntu, so we download the Linux version. After you download, you can unzip the file, and you can open the UA Expert by double-click. You can input your organization name and keep the rest as the default, then choose OK. Now the UA Expert is running, and we ensure the OPC UA server is running. And we copy the OPC UA endpoint from the program and put it to here. Then we should give a configuration name. Then we can check OK. Then you will see the new created server in the UA expert. Right-click the server and click the connect. Then you can see the server variables in here. You can drag and add the variables to the middle window, so you can see all these variables here. There are warning messages in the patch such as the attribute is missing stuff, and the error messages in the UA expert, such as the acknowledgement stuffs. It is only the bugs of OPC UA packages and the UA expert software. This is not affect the software function. Then you can just ignore these messages. Now you can create a client to read and write the variables in the server. We can create a file here and we rename it to OPC UA client.py. And we also need to change the properties here and permission to allow executing. Then when you go to back the software, you will see the client here. Double click open. Then I have created a demo program for you. You can directly use from my video. And first I'll create a function here. This is just create a client, so it will help me to simplify the program. And this is the main function. We create object. This is used to read all the objects in the server. And the server is looking like this. First is root objects, server and the Nachi robot folder and Nachi joints. So this is used to read all the objects here. Then based on this object, we get the children under this object. And first we will read the Nachi robot, this folder that is here. Is browse name here is 2 and the Nachi robot, so we put 2 and Nachi robot here. Then we go this, and after this line we will create another get children function. This is used to get the Nachi joints, that is this one, Nachi joints. We also get the browse name 2 and the Nachi joints. And after we get the Nachi joints, we will get each of the joint values. So we have these 6 joint values here, so we can use this method to get all these 6 J1 to J6 values. And I also create a loop here for 100 times. First I will read the values, each of the 6 joint values. Use this method, and I will print out these J1 to J6 values, and I will set values to some random value. Then I will make a 0.5 second sleep, and I will run this main function. We can create to make it run. Then it will read the values and set it to the new values. Also in the server, it can change here. It will loop for 100 times. Our method is to run this client method on the robot controller, and it will constantly read the robot values on the server and update the local robot joint values, so the server variables can control the robot variables in the physical robot. So we can control our physical robot by OPC UA. We have running the OPC UA client and OPC UA server on our system. We open the UA expert on one of our Windows PC, which is connected to our lab PC. And we point the PC camera to the robot, so you can see the camera view in the screen. Then we change the values in the UA expert. This is change the values to the server. So the server change the value will feed back to the robot system, and the robot will move according to our setting values. For the safety concern, the robot speed is set to a very low speed, so the robot cannot move very fast.